So this is the LLM 101 session, and we are going to take a brisk look at large language models, and we're going to do so in kind of a hopefully fun and interesting approach. So let's take a quick demo here. I'm going to switch right to a live system if I can. Where is that thing? Here we go. All right, and so I've got a few files here. And the GPT Python guy, there's a link to this code, and you can see it's really small, right? It's 10K. So this is our general pre-trained transformer LLM. It's a complete LLM, soup to nuts, and it's all in there with the exception of some Python libraries or some PyTorch libraries for the math, right? And so this will show you the structure of an LLM, and we're going to kind of go through it. But let's start by running this exact code, and you can see that this is actually a little bit smaller because this guy just has the training part commented out. So I'm gonna run this guy, and let me just tail. All right, and so you can see what we're gonna do is we're gonna say, hey, I want to set up a prompt here. That wasn't quite enough. So we're going to set up a prompt that is friends, Romans, countrymen, lend me your ears, right? And all the training stuff has been commented out. And we'll go through all this code hopefully by the end of the seminar. But now I'm going to run this guy, right? And so this is a model, or is it? I don't know if I would call it a model. It's an algorithm, right? We have set up a GPT stack. We've got all of the stuff that we need to make an LLM, and it's all in place. And we're going to give it this prompt, friends, Roman, countrymen, lend me your ears, and we're going to see what it spits out. But it has never been trained. Its weights are all just random values, right? So what we get back is, okay, friends, Romans, countrymen, lend me your ears, right? Semicolon, that's the end of our prompt. And now it starts predicting tokens. And it's D3H space colon, quote, semicolon. Okay, right? So that's not very impressive. This is a model that isn't really a model. It's just an algorithm, right? It's not a model until you train it, until you give it learned weights that it can actually do useful stuff with, right? Models have learned from data, and this guy clearly has not learned from data. All right, so let's run the regular GPT guy and let him do his thing. Now, it's kind of built. I should have just ran the one that loads the model, but I started it, so I'll let it go. So what this guy's doing that's different is it's actually doing the training part. And let me do this. While this is running, let's take a look at our data set. All right, so this is our data set. It's just a bunch of Shakespeare stuff, right? So we would expect if you train your model on Shakespeare, it's going to talk like Shakespeare, right? So let's see what happens. Okay, it's only about halfway done. So let me post a little bit more. This is running on an NVIDIA consumer-based graphics card, right? So you can see this particular card's a GeForce RTX 5060 Ti. It's got 16 gigs of RAM. In general, when you're doing AI stuff, you want the more RAM, the better. I would much rather have a 3090 with 32 gigs of RAM or 24 gigs of RAM than this card. Even though this card's much faster computationally, the size of LLM you're going to be able to get into 16 gigs of RAM is a lot more conservative. Now, our guy is pretty small. You can see he's only taking up 4 gig, right? So this is a really teeny little model. But at the end of the day, we're using up, pretty much all of our GPU, and we are consuming about a quarter of the memory, but with a very, very teeny little model. So you start running bigger things, and you're going to get, more consumption, of course. So here we go again. Friends, Roman, countrymen, lend me your ears, semicolon. That's our prompt. Hey, look at this now. Come his none, must would 'tis nothing. That sounds Shakespearean, doesn't it? It's a little bit, mushy, but hey, we just trained this guy in 1 minute and 34 seconds. So not bad, from random characters to, hey, Camilo, nay, you have been the poison mine for your I hope the severance or sedence. Yeah, it sounds very Shakespearean. Doesn't make any sense at all, right? But hey, clearly this model has learned a lot about how to put words together, how to space things, that sort of stuff. So we've got a lot of benefit from just a very, very short period of training. And also that file is only a meg, right? So there's a whole bunch more learning, we could do to try to take this guy to the next level. Okay, so yes, demo of an untrained model, a look at the input file that we used and a little bit about the GPU that's involved. The CPU on this box doesn't matter, everything's happening on the GPU. The CPU is at like 4% when we're doing the training in this case. So if you could possibly get a GPU, you're going to speed yourself up, probably an order of magnitude or two. And that's always something that you would like to do if you're tinkering a lot, because it'll save you tons of time.